Hello, class. We're about to start section 2.1, Follow the Pattern. We're on page 111. Our learning objectives is to recognize patterns and use them to make predictions, and also to distinguish between linear and exponential growth. Now, on page 112, it says here, how good are you at recognizing patterns? If you look for them, they're all around you. In some cases, these are patterns and things you see all the time, but never really thought about in terms of patterns. Two examples of visual patterns are shown here. The QR code will direct the smartphone to the website of the St. Louis Cardinals. The UPC is for a 12-pack of 7-Up. Try them if you don't believe me. They may look like a bunch of squares and lines at first glance, but there are definite patterns for the discerning eye that knows what to look for. One good way to practice recognizing patterns and anticipating where they lead is to study strings of numbers and letters, looking for a pattern. In questions 1 through 8, find and describe the pattern, then use it to make a reasonable prediction for the next 3 symbols. Okay. So we have 3, 6, 9, 12. If you notice here, these are going up by adding 3. So since we're adding 3, that would mean that the next would be 15, the next would be 18, and the next would be 21. Now we come here. Now if you notice, it goes 3, 6, 12, 24. We're multiplying by 2. So this would be 48, 96, and 192. Now for number 3, we had 3, 20, 160, 80, 40. You notice it's going down. Now one thing I didn't say that I should have said earlier was that when you're looking at a pattern, the first thing you should look for is whether or not it's addition or subtraction. If it doesn't fit those two, then you should try multiplication and division. So here, in order to subtract, we would subtract 160 to go from 320 to 160. But then 160 minus 160 is 0, so that doesn't work. And then what we could do here, we could do division since it's going down. If we divide by 2, this works. So 40 divided by 2 is 20, 20 divided by 2 is 10, and 10 divided by 2 is 5. Now we come here to number 4. We have 320, 240, 160, 80. It's going down, so first we'll try subtraction. This goes down by 80. This went down by 80. This went down by 80. So we're subtracting 80 from each value. So this would be 0, negative 80, negative 160. Now we have ADGJ. Now if you notice, if you look here, we know B and C goes in between those values. E and F goes in between those values, and H and I goes in between those values. So what we're doing, we're skipping 2 letters as we go to the next letter. So if we skip 2 letters, that'll be L and M, K and L, and then that would leave us M, and then N and O would leave us P, and then we would do R and S, and that would leave us T. I'm sorry. I guess I'm off a little bit. P, after P is Q and R, and that would leave us S. Yeah, I'm not used to skipping letters. All right, now, if we look here at number 6, we go 1, B, 3, D, 5, F. Now we know 1, and then B is the second letter of the alphabet. 3, D is the 4th letter of the alphabet. 5, F is the 6th letter of the alphabet. So then this would be 7, and then we have to do the 8th letter of the alphabet, which is H, and then this would be 9. All right, now number 7. We have 1, 1, 1, 2, 2, 3, 3, 5, 5, 8, 8, 13. Now, if you notice, when you add these two values, it gives you the third value. 1 plus 1 is 2. Then you do 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21. 13 plus 21 is 34. And 21 plus 34 is 55. Now, if we look down here, we had JFMAMJ. Now, I'll admit, I had a problem with this at first. I thought it was some type of pattern with the letters, like it'll be an M every so often or a J every so often. But actually, these are the months of the year. This is January, February, March, April, May, June. So this would be July, August, and September. So that's the first initial of the months of the year. Okay, so now we took care of that. Now we need to move on to the next page, to be page 113. It says the familiar UPC codes that are used to find the price of an item have something called a check digit. That's important in avoiding scanning errors. Obviously, it's important both to the store and the buyer that prices are entered correctly. To practice following a procedure, read the instructions below carefully, then use them to answer questions 9 and 10. UPCs are 12-digit codes. A 12-digit universal product code has 3 parts. The UPC has a 12-pack of 7-Up. It's shown on the previous page, and it tells you this is the UPC code. The first 6 digits of this code, 078,000, identify the manufacturer. The next 5 digits, 01180, are the item number identifying a specific product from the manufacturer. And the 12th digit is the check digit. When the item is scanned, the reader performs a calculation on the first 11 digits. And if the result doesn't match the check digit, the machine knows something is wrong and the scan is rejected. There's a 5-step process to calculate the check digit in a UPC. So we go here, computing a UPC check digit. Step 1, add all of the digits in the odd number position. The first, third, fifth, seventh, ninth, and 11th. Step 2, multiply the results from step 1 by 3. Step 3, add the digits in the even number position. Second, fourth, sixth, eighth, and 10th. Don't add the 12th digit. Add the results of steps 2 and 3. The check digit is the number you have to add to the result of step 4 to get to the next multiple of 10. Now, basically, and if you notice here in parentheses, that is the next number that ends with a 0. So we're going to go through this. It says check the UPC for 7-Up provided above has the right check digit. Show all of your calculations. So let me write out the UPC code. Okay, that's the UPC code we're dealing with. So we'll go to step 1. We're supposed to add up all the digits that are in the odd positions. So it'll be 0 plus 8 plus 0 plus 0 plus 1 plus 0. And when we add all of this up, it gives us 9. So step 2, it tells us multiply the result from step 1, which is 9, by 3. So it'll be 9 times 3, that gives us 27. Step 3. Now it tells us to add the numbers in the even number position, but we don't add the 12 digit. We go from 2 to 10. So that'll be 7, 0, 0, 1, 8. So it'll be 7, 0, 0, 1, and 8. Now when we add all of this up, it gives us 16. So step 4, we're supposed to add step 2 and 3 together. So it'd be 27 plus 16, which is 43. Now step 5. We're supposed to find the next number that ends in 0. So 43, the next number that ends in 0 is 50. So we would take that number minus the 43, and that gives us 7. So our check digit here is supposed to be 7. So with that being said, we look here and you notice the check digit here is 7. So it has the right check digit. Now, some of the problems that you're going to encounter will only have 11 digits. So you will be actually finding the check digit and it won't be given to you as is shown here. So now we move on to the next page. It says, repeat question 9 for the UPC as given there for us. You will be asked later to find what product the code corresponds to. So we'll start off with step 1. We add up all the digits that are in the odd positions from 1 to 11. So it'd be 8 plus 5 plus 0 plus 5 plus 9 plus 4. So when we add all of this together, this would be 2731. So we'll do step 2. Now we would take the answer from step 1 and multiply it by 3. That would be 93. Now we do step 3. Step 3, we add all of the even values except for that 12th digit from 2 to 10. So we have 8, 9, 9, 9, and 6. So we add these together and that would give us 41. So step 4, we're supposed to add the answers from step 2 and 3. 93 plus 41 is 134. And then step 5, we need to know what number would make this equal to the next number that ends in 0. The next number that ends in 0 is 140. So we'll take 140 minus 134 is 6. And if you notice, our check digit matches up. Now we go down here to number 11. It says use the internet to look up the UPC code for a product that you've bought recently. Write the UPC code below and verify the check digit. Now that's something that you could do at your leisure. So just to let you know, just look it up at your leisure and you can do that. All right, so now we move on to the next page. Now just to give you a heads up, we only have 4 more pages that we need to complete and we're done with section 2.1. It says number 1, if I offered you one of the 2 accounts detailed below, which would you choose? More importantly, why would you make that choice? Now, if you look here, and I would just say me, I would look at the end of the time here, which one has the most. So myself, I would pick account 1 because after 4 years, there is more in the account. Okay. Now it says, let's take a more in-depth look at some patterns like the ones that began this lesson. Number 2, describe the change from one way to the next in this pattern. 2, 5, 8, 11, 14, 17. Be very specific. That's way more than just specific. So basically, if you look here, we're adding 3 to each value. So we would add 3 to the previous value to get the next value. So we'll add 3 to 2, and that will give us the 5. We'll add 3 to 5, that will give us the 8. 3 to 8 give us the 11, and so on. Number 3, it says repeat question 2 for the pattern 2, 6, 18, 54, 162, 486. Still expecting very specific. You notice here, first we'll try addition. We'll add 4, but then 6 plus 4 is 10. That doesn't work. Now, we wouldn't do subtraction or division because the numbers are not going down. So we can do multiplication. So 2 times 3 is 6, 6 times 3 is 18, and so on. So we'll multiply 3 to the previous value to get the next value. Okay, now it says both of the lists above start at 2 and get increasingly bigger, but in different ways. In the first list, the value grows by adding. Don't give you much space here, but adding the same constant number. This type of growth is called linear growth. In the second list, the values grow by multiplying by the same constant number. This type of growth is called exponential growth. Okay, so if you add by the same amount, it's linear growth. You multiply by the same amount, it's exponential growth. Now, it says, is exponential growth always going to result in faster growth than linear? Think about it. Try some examples and explain your answer. All right. It's not always. Most cases. Because it depends on the amounts used. For example, starting with 2, if you add 60, well, let's say 60,000. If you add 60,000, but only multiplying by 2, linear will grow faster initially. Okay, now it says the spreadsheet to the right shows an example of linear growth. What's the next value on the list? You go 35, 45, 55, 65. You're growing by 10, so the next value on the list would be 75. Now number 8, it says write a verbal description of how you would obtain the value in cell A6 from the value in cell A5. Now, using a program like Excel, you would typically type in the equal sign and you would type in A5 plus 10. And that is for you to get A6. Oh, you know what? Actually, I skipped over a problem. Actually, this is supposed to be for problem number 9. We're supposed to write a verbal description for problem number 8. We're supposed to put add 10 to A5. And this is the actual thing you would type in. Okay, number 10. What value would appear in cell A12? This takes either repeated calculations or some ingenuity. If you have Excel available in class, feel free to use it. indicate how you got your answer. Now, it says here repeated calculations. Now, if you look here, with linear, we keep adding the same amount. Now, remember back when you were first learning addition and then multiplication, we know that multiplication is just repeated addition. So basically, from A6, we have, that'll end up being 85. But from A6 to A12, that's 6 values. So if we did 85, which is A6, plus 10 times 6, because remember, you're going to add 10 6 times. That would give us 145. Now, if you had wanted to write this out, what you would have to do, you could say equals, you could say A6 plus 10 times 6. This is how you would type it into an Excel sheet. Or if we have what A11 is, we could just put A11 plus 10, either one. Okay, but this right here is the actual answer for what would be in A12. All right, now we move on to the next page. It said the spreadsheet to the right shows an example of exponential growth. All right, so if we look here, we go 2, 20, 200, 2,000. If you notice, they're going up by multiplying by 10. So they ask us what is the next on the list. You take 2,000 times 10. That will give us 20,000. So this would be 20,000. Now it says write a verbal description of how you would obtain the value in cell A6 from the value in cell A5. Multiply A5 by 10. What would you type in cell A6 to calculate this value? So you have equals A5, and typically it has a star symbol for the multiplication, times 10. Or it could be the X, I'm not sure. It depends on your computer as far as the Excel is concerned. All right, it says, what value would appear in cell A12? This takes either repeated calculations or some ingenuity. If you have Excel available in class, feel free to use it. Indicate how you got your answer. Okay, listen. We could go here to A6 because we know we'll multiply this by another 10. So that'll be 200,000. So we know it'll be 200,000. And then times. We know it's going to be times 10. But remember, with repeated multiplication, that's where we come with the exponents. So from A6 to A12, we will be going down 6 places. So it'll be times 10 to the 6th power. So it'd be 200,000 times 10 to the 6th power. So we know we would just add 6 more zeros. And that will give us our final answer. So this right here would be 200 billion. Okay, now we go down here to the bottom. It says, now let's study these two types of growth in a little more depth. By the way, we'll study linear change more in lessons 2.2 and 2.4, then study exponential change in lessons 2.5 and 2.6. 15. Suppose that you're offered 2 jobs by a very eccentric but lovable billionaire. One pays $40,000 in the first year with a salary that increases by $10,000 each year. The second starts out at 50 cents a day, which I imagine probably violates minimum wage laws, but whatever, and doubles each month. Which job would you be inclined to choose and why? Now, I would say this 50 cents a day. Let's just use a 30-day month. 50 cents a day, that'll be $15 for the whole month. And then it doubles. Then it'd be $30 and then double and be $60. Now, I would think that most people would pick 40,000 a year with $10,000 increase each year, because the 50 cents a day seems as though it would take a long time to make a decent salary. Okay, now we come here to the back. It says, how much would you make per month in the first year with 40,000 per year? So you'll take your $40,000 divided by 12, and that will give you $3,333 and about 33 cents per month. Now, going with the 30-day month to keep the calculations simpler, how much would you make in your first month on the second job? So we talked about that, 50 cents a day times 30 days. That'll be $15 for the first month. Okay, now 18. It says, fill in the table below with the monthly salary for each job over the first year. Remember, the first one offered a raise only after the first year, while the second one doubles each month. So basically, this is how much you would make the first month, and you will make this all the way down here. Now, technically, this is slightly off by a couple pennies, but this is about how much you would make per month with the $40,000 a year job. Now, here with job 2, first you would make $15. Then you would make $30 because it doubles each month. Then $60. Then $120. Then $240. Then $480. Then $960. Then $1,920. Then $3,840. Then $7,680. Then $15,360. And then finally $30,720. Now remember, this is monthly salary. So now it says, how much more money would you make in the first year if you had the foresight and math skills to choose job 2? Now job 1 will make you $40,000. Job 2 will make you $61,425. So in the first year, by doing the doubling each month, you have made $21,425 more with the second job. Now, I'll admit, even though the second job pays a lot more, there's not too many people that could wait till about the 8th month to start a decent salary. And you see these amounts here were not that high initially. But it's good that you know that the second job actually pays more, which is a good thing. So with that, that ends section 2.1. And we are done. Have a great day.